Hello guys, Dragon here. In this video I will explain you how to make a quick script so that you can find your health value more easy. This will not be too much of an advanced script because at the end of the day the purpose is just to show you how to more easily find this health value. Because if you watch my previous video about my previous tutorial about Annelids on how exactly to find this health value, it took us quite some time, so of course we want to like automate this process and make it more simple for us to find it. So usually the way we do that is also like by using pointer search and looking for pointers that point to the lib, so that we can make like offsets or like string searches. Like we can do a lot of things actually to find our value more easy, so yeah, just follow through with me and it should be fine. It's also important to know that like the version, well, not the version, but I'm using the 64-bit version of the game. That's the architecture it's running on. So if you are using 32-bit, you might not be able to follow this video, or at least try to install the 64-bit version. And yeah, if it's not possible, it's not a problem, because the concept is the same anyway. It's just that the pointers are 4 bytes for you, and in this video it will be 8 bytes. But it shouldn't be a problem. If you're a little bit familiar with offsets, you can kind of follow this video in a way, because the structure will be more or less the same. So yeah, just so you know, make sure you watch the previous part of this tutorial, part 1, where I was explaining how to find this value, okay, with just an unknown search. And then after that you can follow this video, since it will make a bit more sense, I assume. And yeah, like I said, like we're not going to do too much of scripting in this video, just like something quite straightforward. And in my other video, like the next one, I will give more like a more serious scripting video about this game, where we're gonna like map out like all the gun stats and the entire character stats, and as well the character stats of all the other players involved in the game, like the AIs and like actual players, just for the sake of it, actually, for the sake of the scripting. Also, don't expect like any like professional level of scripting. Like my little scripting is really basic, so if you see like mistakes, it's always possible, of course. I'm totally prone to mistakes, makes a lot of sense. And of course I only make the videos for teaching, for shared knowledge. So yeah, let's go now to the let's actually start doing something, because I'm talking too much. So we start, we're going to the address. We have our health value here. Actually, let me just show you again the health value. So if we free, like I just froze the value, so my health will not be affected. If I unfreeze the value, I will die, and see, I just died. So let me respawn. So yeah, like I just died. So the first thing we should check is like how to, like, where can we find some pointers. You have to set the data, like you set the value format on quart, because you're on 64-bit. So when you want to find pointers, they're gonna be they will be colored in 8 bytes. That doesn't mean that the pointer size is 8 bytes, but it just means that addresses are maximum 8 bytes. So you put on quart, okay? If you are on 32-bit, you put it on quart, because the addresses are like on 4 bytes. So then you put on quart, okay? And you can leave the string enabled, and you also put on the hex and little Indian notation, so that we can actually see the colors that gameguardian shows when the value is a pointer, okay? And I don't know, if you don't know what a pointer is, it's just a value that represents a memory address, okay? So this is a value, and these are memory addresses, all right? What it means, the pointer is just that the value is actually the same as the memory address, okay? So it's an address and memory. That's what's a pointer, okay? So yeah, we also enable actually the dword because most of the stats are actually in data type dword. Like our health, it's in dword, so it's actually word. It's only 2 bytes that will change, but a lot of stuff is in dword. Continue with the health value. So what we need to do is we need to find a pointer. All right. So we need to find a pointer. Like the most easy pointers to use are the ones that point directly to a library. Okay. So if we scroll like more up, we will find something decent. Oh, look, we have a pointer that points to a library. So and pointers are marked in color. So this one is in like pink kind of. So you save it in Word. First thing we do is like calculate the offset between those pointers, between those values. My apologies. So you use the offset calculator. You see like offset, and it's like 154 in hex. Okay, so like that, you know the distance from the health value, or actually from the pointer. You know the distance from the pointer to the health value is 154. Okay, so what we're gonna do now is we're gonna check where this pointer leads to, because at the end of the day we need to make a script. All right, so we use the future go to pointer. So what it will do is like it will go to this memory address. Okay, so this is the value and it will go to this memory address. So you see that it points to a string in a library. Okay, so let's first see like what the name of the string is actually, and we can also see then the name of the library it's pointing to. So let's do this again. I enabled byte because it's not pointing, the pointer is not pointing to the address that ends with DF44. It's pointing to an address that ends with F46. Okay, so it's this one. It's pointing here. Okay, but you could not see that because I didn't have the byte enabled. So if you don't enable the byte, gameguardian won't show you like every address. Okay, so let's show again. Go to pointer. And here you are, you know, at this address. So we can see what is the name of the string. We disable the quote so we can properly copy and read the string name. So now we only have the byte view enabled, and this was the address we were going to. And every string is like closed off with a null byte. So a null byte is just a value in the memory that is literally null, and because it's required for the game, like to know like what is a true string. You can call it a true string because true strings are always closed off with 0. So you copy the characters until you reach the 0, and then we can easily read it. You don't need to do that. You can also just read it with the eyes, but gameguardian has this nice feature that we can copy the string, copy the bytes, sorry. It will make a beautiful string for us. So this is the name of the string, 3/26. So we can copy this for later use. But actually what you want to really do is like copy this, because we are in a library. So for make your search more accurate for later on, you're gonna copy like the both bytes, like the one at the front and the one at the end. You know, the one at the end is just the end of the string, and the one at the front is the end of the next string. Okay, but like this, we tell gameguardian to specifically search for something with 003/2600. Okay, so usually that will just work out. So we copy this, and you copy this in hex because we're gonna search in byte. Okay, we're not gonna search in UTF-8. We're gonna search in byte later on. So you can copy this. Later we go back to this. And now let's find out in which library this string exists. So we copy the address, and then we go here, and this future will show us all the regions, like basically a memory map will show us. It's really useful actually. So the address we just copied, we paste it here. Actually, just for accuracy, actually I should just copy this address. It doesn't really matter, but it's just for cleanness. We copy the start of the string, okay? And this is actually the start of the string. This we just copied extra so that we have less results when we search for it. But this is the start of the string, all right? So we copy that address. And then you can see, gameguardian will show you in which range that address exists, in which memory map. So it exists in the library lib_annelids.so. So that's the library we have to look at later on. Okay. Let me do something. Let me just copy this bytes, hex. And let me go to I just made a simple Lua file, and I just call it testing stuff because I'm always testing stuff. And I will copy. Don't worry about this. This is just some other testing stuff unrelated to the game. So I make a comment and I put this hex so we can search it later on. And for readability, I also copy the string name 326. It's the same thing, all right, more or less. But it's just good to know always what's the name of that function, or symbol name, I guess, which is just called 326. These bytes is equal to 326. It's the same meaning, right? So we go back. Now that we got that sorted, we need to see if this is actually useful. So I disabled the byte view, I enabled Word again, and let's see. Let's go back to where we started. So this was the pointer that we had, the one that we saved, the same one. Now we should actually restart the game, and we should see if we can find the health value through this pointers. So basically what we're going to do is we're going to first search this string, the one that we just copied, the 326. We're going to search it in this memory region, and this one we're going to search it in this lib, and we're going to see if we're going to have results, which we should have. And then we're going to perform pointer search. So let me enable this byte. So after we search the string name, after we search the string name, it will show like this in the result list. Let me load it. It will show this. All right. It will show this actually with extra byte. Sorry. This is what it will show. And we will perform pointer search on the first character of the string, which was this. Okay, so we delete this, and we perform the pointer search, and we perform the pointer search in the memory region A, I believe. Let me see. Yes, no, sorry, and the memory region CB, because or pointer, the address that holds the pointer to the first character of this string, so to address df46 is in region CB. All right, memory region CB. So we disable all the irrelevant regions, and we only keep CB open. Okay, we can disable this. This is in theory what we're going to do in the script later on. So now we can perform the pointer search. Basically, all it's going to do is search for this value and see if there is if this value can be found somewhere. Okay, and we put the offset on 0 because we only want to search in this range basically. Okay, so we don't want to look for any offsets, and you put the hex on, and you can put the data type if you want to, but you can also leave it on auto. And then we search, and here we have our result. So the value was found one time, and that memory address ending with 600, which is the same memory address as here. So we found the value. So now we need to confirm if this is a valid pointer, you know, that not if we shut down the game and we restart it, that we won't find this pointer again, you know. So we need to check this. So let me just restart the game then, and we have to remember the offset also. So the offset was 154. So let me also write down the offset for, oh, not bad. So yeah, we have our offset and we have our string name. So let's go, let's restart. Restart. All right. So enable gameguardian again. We select the. We don't have to select the process, but I always do it just in case, because we press like restart and gameguardian should just restart the app, but sometimes I do it anyway. So yeah, what do we do? So we go to XA, where we found the lib annelids.so, and we search our value or string. So we copy this. I told you we're gonna search it in bytes, and we include the no characters, the no bytes. Okay, so we search, copy. So we have 6 results. So we found our string. So this is like what I told you that we were gonna find it here. So if you go to the address again, like this is just the same stuff I showed you like 1 minute ago. Okay. So if you don't believe me, you can copy this address and you paste it here, and you can see we are back. The value could be found in lib annelids.so. Okay. So we found the string, and we copy like the first character of the string, which is this one. And just like I said, like the pointer was pointing to the first character of the string, so that's why we need to perform pointer search on the first character of the string. Okay. So what did I say? We had to go to region CB because the pointer was in region CB, and our health value also. So we only enable CB. We perform the pointer search. You can leave it on auto or on quart, whatever works best for you. Don't put word because we are on 64-bit, so addresses are 8 bytes max. So you put on quart, and here we have our value again. One value, like one result. Sorry, region CB. You save it. We have our address. And the offset was from this pointer, like from this address to the health value was 154 hex. So you can use the offset calculator. Well, the offset, it's not the offset calculator, but in a way, what it does is like you give it an offset, and then you press copy, make a copy, and then it will show you like the address at that offset, and it will put it in the save list. Okay. When you make the copy. If you don't put copy, it will just replace the current address with the new address that you provided using the offset. Okay, so current address plus offset it will do. So just make a copy, and our health value was in data type Dwart, so you put Dwart. At least that's how I showed it. It's actually Word, but you can put it Dwart. Okay, and then you press OK, and now like it's 0 here, but that's because we haven't entered any game yet. So let's enter the game from training mission, and we play. We move a bit around. However, it doesn't really matter, it seems, because if you remember, this was the way our health value looked when we were playing, but we can test it out. Of course, I just need to go like through this annoying maze. which I really don't like with these controllers. I try to do it fast. Let me pause the video so this goes a bit fast. Okay, yeah, so I made myself some way through the parkour. It was a bit of a pain, but well, here we are again. So I freeze the value so we can just double check if this is correct. Let's see, I burn myself here, and you see I don't die, so my health value is just the same. So this is the good value. If I unfreeze, I'm dying, and here we go. So we're back at it again. So this means that we found a good value. So all we have to do now is put what we just did manually in a script. So let me show how we put it in a script. So to put it in a script, we can first start with if you can use Zero Brain IDE to start writing Lua scripts. It's really nice to use, but you can use any editor, of course. But first thing first, we can make a function, because what we need to do is we should first get this range, the lib Annelids.so range, wherein our string value was located. The reason why we don't just do search string without any like range is because the search will be slower. But if we tell gameguardian to only search between this address and this address, or like just this address and this address and this address and this address, it will be a bit more fast. Okay, so actually I don't start to write functions right away. I put stuff in functions later on, but maybe I should just do a function. So you write like function, and then for example you do like, you call it like lib range, and you close it and you put end. Now you have a function that's closed, and then what we have to do is we have to use this function, get range list. So this is on the gameguardian forum, the documentation. Always check it out because it's really useful. And here it says what it does. It lists a table with memory regions. Okay, each element is a table with fields, state, start, end, type, name, internal name. What we need is the start and the end of each memory region. Well, we need the start and the end of the memory region in which lib Annelids.so is located. So they will give us the start and the end of this address to this address and this address to this address. This is the start, this is the end. All right, so we can type in a string name. So the string name will be lib Annelids.so. So put local. Then you could call it like lib. Let's say this maybe. You can always like, oh, we just call it range. It's always a problem, like for me personally, like with variable names, it's a tough one. So get range list, and then you put the name of the lib, which is lib analog, I think. Sorry, let me see again. And lib Annelids. Alright, that's that. And then let me see. So now what happens is like we can use the print. Let me just put a print to show you range, what it kind of looks like. So let me execute the script. Testing stuff. I cannot find it here. Let's see. I think it was here somewhere. Yeah, this one. Well, that's interesting. Doesn't show. Oh, yeah, of course. I didn't call the function, of course. So let me execute again. So this is what it will show. It's a lot of results, of course. That's not we don't want that many results. But what we would be interested in is this. Actually, this is what we are interested in, because this part, this table is the table where the string is located. Okay, I don't know if you can make sense out of this, but use this as an example. Here you have XA, 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 and then CD, 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 CB. Okay, so if we take this, it's the same pattern, right? XA, XA, XA. Okay, you can ignore the O, but because I said that we're gonna look for lib Annelids also, so gameguardian is looking for strings with lib Annelids also. So XA, 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 and then CD, CD, and then CD, and then CD again. Okay, so it's exactly the same thing like you would see here. So what we have to do when we execute this is we just have to use the first table, right? Well, this is one table and those are subtables. Okay, so we have to use the first subtable, the first index. So what we can do is like, you can say like well, since we know it's the first one and there's only one actually, you can basically say like, let's remove this, return range 1, then the start and range 1 and so now we will return, like whenever we call this function, we will return the start address and the end address of the first subtable, okay, of the first index actually. So we will return those two values, start and end, which is equal to this, to the start address and the end address where our string is located. Okay, so now we just need to put variables that take that, so we can say like local and then like lib end, so lib start and then lib end is equal to lib range. So range 1 dot start will go into lib start, and range 1 dot end, range 1 end, sorry, will go into lib end. Okay, and then later we can use this to search our function, to search our value. Okay, so but like I said, usually I don't start with writing functions, I add them later on, but maybe that's not a good habit. Okay, so now we can make a function like function search string. I just shorten the search to SRCH. Not everything has to be like written out in full. And so what we're gonna do is like, we can now use these variables. Like we can use the start and the end. So we're gonna do our good search number and the string name, which was this, and bytes. We put it here, well, between quotation actually. So what you tell here gameguardian to do is to search this string. It's the same as what we were doing manually. And then we need to put the data type, which is a byte. So we put good dt.type and then byte. And then you put nil. The reason why is I can show you actually. You have to look what search number actually does. Search number. You can see like the first argument is a string, then an integer like that represents the data type, which we have. So we have the string, which is the string name, like the type string, right? And then we have the data type, which is type byte. And then here it says like a bool for encrypted, but we don't do any encryption or something, so we put nil for the next argument. And for the sign equal, we don't put any sign, whatever, so we put nil. But then we have the memory range, so the memory start and the memory end. Okay, so the memory start is for us the lib start, and the memory to, so like, yeah, memory from is lib start, and memory to is lib end. And limit, we don't need to put any limit, so we can just ignore that. So here we go, we put lib start, and then we put lib end. And like this, we have everything we need. So we tell gameguardian to search basically within this section. All right, and then we can test it out. To be honest, we can just run this. Then let me call the function string. It should work unless I'm forgetting something. Oh yeah, also what we need to do is we need to set the memory range. Okay, we have to tell gameguardian that it has to search in the memory range XA. Okay, so basically this. Okay, because at the end of the day, our lib or string name is in the range XA. Okay, so you can use set range, and then you put type range, I remember, and then code. No, you don't have to put. Sorry, even me, I need to look now. I don't believe it was like this, but let me see. So you have the ranges here that they mentioned. So, okay, so it's region code app, not range. So you have to region. So region code app, and yeah, now we can run this just to test it out, see if it works. So we execute. And we have the result. So it did not matter what you select here in gameguardian. You can even put everything off. The script overrides it. So let's run it again. So good. So it found our string. Okay. So we are doing good. Now we need to make a table that where we can store the results in. So we need to store the results. And so we can use the gg.getResults, and we store it in the variable t. So local t equals, always put the local because you just want this variable to exist. Like you only want the scope of the variable to be within the function. You don't want it to be like outside of the function except for the ranges. But even that you don't necessarily have to do. But for me, I make that a habit. It's good practice to use as much local variables as possible. So actually even before that, all right. So what we need is the second character. Well, we need the first character of the string, so that is this one. But we have like 6 results, so we have to at least tell gameguardian, like we at least have to select 2 results. So this 2, all right. The rest we don't need. So we can put 2 here, okay? So what this will do is gameguardian will select two results. So it will be these 2 it will select, all right? So that's what we can work with. So I can show you if we print the table, like print t, and we run this, then we remove this, and we run. We have 2 results. So here you see the address of those results. So you can see F45, and the value 0. And this is the address of our first character. Okay, the next address. So 45, 46, and here the value of 51, right? Which is totally accurate. So what we're gonna do now? It's like we need to perform the pointer search, all right, on the first address. sorry, on the first character of the string. For me, I like to make a new variable, call a pointer, and set it equal to the first, like the second index. All right. So basically, like the second address. Sorry. So this address here. So you saw like our table. So let me just this quickly again. You saw our table. So the name of our table is T, and we need to access the second index and the value and the address. Okay, this one. So we do T2 and then dot address, and that will be the one where we will perform a pointer search on. Okay, so and then you just return. You can return it if you want, or we can search it right now. It's not a problem. We can do that. So we actually, what you do now is like you set the set range, and you set it to what we call this. So we need to set it to CB. All right. So let me just see in the documentation how we call it. So CB is like it's the same, right? CBSS is the same as CB. Okay, you can see that here. It's the same meaning. So this is what we call it, region CBSS. So we do this, then voila. Because we're going to use the pointer search feature, we need to load the results again. So we need to load results T. It's a bug in gameguardian, but we need to do this. All right. Whenever you try to use the search pointer function, we need to first, like if you try to use it and in another memory region, and that memory region is not enabled on beforehand, you have to put the load results first. All right. And now we can do the search pointer. You don't really have to do that. You can also just use search number and then search the address, but this also works. Oh, also, it's good practice to put here clear results, like just so that before you start to search anything, you make sure that the result list is clear. So this will remove everything in the result list. Yeah, we have the search pointer, so it will now search for the pointer in memory region CB. So if we execute this, let's run it. Voila, it happened pretty fast. So we found our pointer. This is the same thing as you find here. It's the same pointer, like the same memory address. So we are doing good by now. So we found our pointer. So now we need to store that result also, and we can just store it in the same one actually. Then get results, and we only have one result, so you put 1. And then we don't need to put local here because we already declared it as a local variable, so we don't need to put it as a local here again. All right, not within the same scope. And then what we can do is like we can return the pointer, so ptr. All right, so you can make a new function, and I guess we can call it like field, or search field, or search health. It's also possible. And we can start to make the offset. So first what we do is like we can remove this, because we're not going to call this function from outside. We're going to call it from inside another function, you know, where we're going to work in. And we're going to call it from in search health function. So we make a local variable and we call it, like, for example, like pointer, and maybe you can call it base or just pointer. It's all the same in this case, in my opinion. So, and you call the function search string, and what it will do is, like, it will call the function search string, it will execute this code, and it will return the pointer value. So it will return this address actually, and it will store it in PTR. Okay, then what we do is, like, remember that the offset to the health value from this address was 154. So what we have to do is, like, we do pointer, well, you can say like local health equals pointer plus 0.154. That will pretty much be our health value, but not just that actually. My apologies. Let me make a small change. What we need to do is, like, we need to store it as a table. Okay, it would be better. So we make actually a table, like you. No, you don't see it, but when we are printing the result list, it's you actually printed a table. Okay, with a table that exists out of subtables, and each subtable represents a result with key and value. Okay, with addresses and the value and the flags. So what we need to do is, like, to recreate that is, like, we need to make a key. We have to use 3 keys, alright? 3 main keys. Actually only 3 keys. Right? So you need the address. So the address that we want is this one. So we need to do this address plus 154x would be this address. Okay, so we do pointer plus 0x 154. You always put the 0x because you are working in hex, and then flags you have to put, which represents the data type. So we put a data type word, you know, for health. So you put word. So GG type word, and that's basically it. Because then all we need to do is get the value, which we don't know. So we have to use the get value function. So we store it in the variable health. So we do health, and then first let me show you how it looks now, the table. So right now the table looks like this. Oh yeah, of course I forgot to call the function dash health. Okay, I made a mistake, it seems. Local health error, attempt to perform error in the table. Oh, okay, I see. I forgot a small thing, because here, like, what happened is, like, when I stored the result in PTR, I stored the table. But actually, what I really want to do is, like, I don't want to store a table. I just want to have this address here. I just want to have this address, this one, on which we then can perform the offset calculation, the 154 hex. So what we can do is, like, instead of returning pointer, which is a table, just to you can have, like, some view on this, just like this. Let me just call this and disable this. We execute this function only. So let me show you. So this is what this function, the search string, was returning. But we don't need all of this. We just need the address. Okay. So we can perform offset calculation on it. So instead of doing PTR, we do PTR and then 1. because it's index 1. Let me show you again. Right. So it's index 1, so you put 1 and then the address, alright, key address. So dot address. So now we have the address. So we can remove this. If you comment this means this won't be executed, alright? So go to search string, and then it will so it stores the pointer, like the address. It will store it in PTR, and then we do PTR plus 154, which is equal to this address, and then we put the flags as dword, and yeah, we store it in health. So if we print health, should be correct now. So now you see we have this address 6754 and typed word 6754. Basically is this address, alright, where we have this value. If we want to see the value, we can use the health, and then we use the get values. Actually, there was another thing we have to do. Yeah, we can do like this, and then we have to actually we can do like this, like store it in another table and call health, but I wouldn't really say this is the correct way to do, but it should work. Let's see. Okay, so now it does work, of course, but I'm not supporting it necessarily. But yeah, now we have the table with the address, the flags, and the value. So the value gets read in Word because we put as typed word. Okay, but basically I would not say to do it like this. I would just do maybe something like I think you could do this, if I remember. Put it between brackets, but I'm not sure now. It was like that or like this, and then we have to remove the brackets. Let me just see if this works. But it works as well. It's the same thing. But you can choose how you want to do it. But basically we made a table and we gave it an index. Alright? So like this. You can add more indexes. You can do like this. It's better like that actually. Do it this way. You can put like index 2, and then you have then you do pointer plus another address, whatever you want, you know. But do it like this. Actually, in my opinion, it's better. So because when you call get values, when we call get values, it expects a table with subtables. All right, not just a single table. It has to have subtables in it. So yeah, we have this now, and yeah, we basically have the health value. So then you can edit it how you want. You can say, for example, like you can do like you can actually just freeze the value, or you can put it to. This is the value when it is false, so you can just copy the word actually, copy the hex, or you can copy the value like this. And you don't have to. What you can do is like you can even put it here when you want to edit the value. You can do it here. Let's say like value, then equal. Then like this, and then instead of using get values, you can use set values, if I remember. Let's see. and you see the value got edited. You also have to freeze it, so I believe you could use like freeze and then you put it to true. I believe it was possible like this. Let's try again. What's possible is that like if you want to freeze the value, we have to put it instead of set values, we could just use add list items. Actually, we could set values and then get add list items, because you can only freeze the values in the saved list. So an add list items will put the values in the saved list, where it then can be freezed. Like this. Maybe it works now. Let's execute again. Right. Bad argument. Table expected, but boolean. We can use the add list items, but you don't store the health. You don't store the return value of the set values every health. Because it's like a boolean, so we can remove this, and all you have to do is like add list items, and it will store the address, this one, which is the pointer plus 154 hex, and it will store the flags in this type of data type, and this is the value that will be put it, and this is the value it will be frozen. Okay, what's also actually, you need to use the set values actually just to set the value. I think it was like this, and then so like that. You tell gameguardian to set it to this value, and with the add list items you tell gameguardian to freeze the value. Okay, so we can execute this again. And done, and now your value is frozen. There you go. It's pretty fast. You can restart the game. And execute the same script. Automation. Our health value. If you want, you can also give it a name. You don't have to, but you can name equals. Put it in a string, like between quotations. Execute again. And here it is. So yeah, this is the end of the video. I hope that everything was kind of clear. I will share the script in the description. Just know like this tutorial is for 64-bit, and also it is not guaranteed that this will work in every version of the game. So I will put the game version, I think it was like grade 19 or something like that. So I will put the game version, so that if you want to try this stuff, you use the correct game version. And also, if any questions, just ask in the YouTube channel, or in the gameguardian forum, or in the Discord channel. And also, like, I will make another video where we do a little bit more of scripting, to have like more detailed information about the characters in our game. All right. You guys have a nice day, and thanks for watching.